Now being recorded.
So, good afternoon, everyone. I suggest we begin, and let's hope other participants will join. So, welcome to the design webinar organized by EeB CA2 CSA. I hope you all understand what I say and you hear me quite well. So just a quick recap on what EeB CA2 is doing. So actually it's one of the first CSA dealing with energy efficient buildings. And so we organize some activities like workshops to establish synergies. We also have dissemination opportunities in international fairs. We organize trainings and webinars such as the one today to deal with technology transfer and exploitation of technologies. And we also propose you some tools and services to increase your visibility. So the program for today, we will have a 30 minutes presentation by Mr. Mader from LISEC. He is from the MEM4WIN project and he will present his technologies. And then I will propose you a Q&A session so you will be able to ask questions and to have an exchange with Mr. Mader. I will explain you later on how to do. And then we will have a short conclusion by my colleagues from EeB CA2, and they will present you in more details the kind of services we propose. So during the webinar, I recommend you to have a phone connection to have a better sound. And I kindly ask you to mute your phone during the presentation to make sure we will not have any disturbing noise during the presentation. So I see most of participants are already muted. And I will be the moderator for the Q&A session. So I just ask you to raise your hand. You have an option like this on your screen. And if you wish to comment or to ask a question, and then I will give you the floor. So this webinar is going to be recorded, and then we will share with you the PowerPoint presentations. Yeah, so these are the participants for today coming from the EeB PPP projects. And that's it. So this is for the conclusion. So I will stop here, and I will give the floor to Mr. Mader. Andres, I give you the floor.
Thanks a lot. Hello to everyone. My name is Andreas Mader. I'm from LISEC Austria and the coordinator of the MEM4WIN project. Today I want to tell you a lot about the stuff in our project. We did there a new technology for IG unit. We used there a smarter design. We used there to get in new technologies in functional integration and functions for the IG unit itself. Oh. So it was too fast. Yes. The targets of our project, the running time was 4 years with 6.6 million euro of budget. We had targets to do an intelligent shading and light control system, which we did with the micro mirrors. They are right there on the top. We came there to an TRL4. Then we had power generation system, electrical and thermal. Thermals you see in the barometric area. We have right here, or the OPV, which we can use as like a printed design in the IG unit itself. Then we have integrating the light. We used there to do OLED technology. The partner was Philips for the OLED. Then we had to reduce the weight by 50% and the costs by more than 15%, which we did with graphene for the functional cost saving, and we did the cost saving in the window with the frameless openable window, so we don't need any frame and we use lesser material in the IG unit. Therefore, we came to NTRL of 7 and 8. The 7 depends on the smallest glass with 0.9 mm and the 8 for the 2 mm glass, which is in the standard right now. And at least we have an U value of 0.3 for the whole unit with argon filling. So these were the targets and our partners. What's about the requirements of an IG unit? The standard IG unit, which you get on the market right now, is a triple glass with 4 mm float. On the outside you have sun radiation, hot and cold temperatures, you have storm, you have rain. Can you hear me?
Yes, yes.
Yes. You have noise, and on the inside you have safety regulations. At least you want to have comfort there, so you want to have reduced the stuff you have on the left side, at least the noises, and hello?
Yes, I'm right, we hear you. Huh?
Okay, perfect.
I'm the only one to be able to speak.
Yes, and what we did for the dimensions of the glass, you need only to use storm and drain on the outside, and at least the safety regulations you have on the inside. So we dimension the glass to the storm and drain, and the inner glasses can be as thin as possible. If you use a safety glass on the inside, it has to be full tempered at least, so there will be a limitation. But on the other hand, there are no mechanical loads on it, and so you can do it as thin as possible. And that's the way we did. So we took on the inside 0.9 mm glass, and on the inner glass a 2 mm glass. On the outside, the standard glass you would use right now. So, yeah, the presentation, yes. So, the ways to dimension the glass on the real requirements, and to get thin glass in use. And to get it in use, you need it to temper it. Otherwise, it's very fragile and will break very fast. So, the market opinion which we took off was, if you use an extra sheet after a triple to get the quadruple loop IG unit, to get better performances of the values, if you use there the standard 4 mm float gas, you have the problem that you will get a bad U value, a bad transmission, a very low durability, at least a high weight because of the extra sheet, and a very high energy consumption in production. This was the opinion the market tells us. And we say, yes, if you use this design of the window, they are really right. So, is there another concept, or is the concept of an additional glass the right solution for us? And we think yes, but with another design. On the left side, you see a triple glass with the standard glass right now. You see they use 12 mm of glass. If you use or reduce the glass to the real requirements, you see that you get spaces at least for the gas on the inside, which give you a better performance for the U value. On the censored glass, You see, this is a possibility which you can use right now in the market. You have there the standardization. On the right side, probably you see a future solution with a 0.9 millimeter glass in the center. And the same options you can use for a quarter loop IG unit. At least on the left side you have the standard from the market, which is not performing, but therefore in the center glass you see a quarter loop IG unit which you can use right now in the market. It has a wideness which is lesser than 60 millimeter, and you can use 2 millimeter glass right now. And it had at least good durability stuffs and so on, but this I will tell you later why it works. And the future glass will be at least a quarter loop IG unit with 70 millimeter wideness and a 1 millimeter glass in the center, because if you want to get to a U value of 0.3 with argon, we use the argon because krypton has 600 times higher energy consumption during the production. So it's the way why we use argon. You have there a glass which has a really good performance and a low energy consumption in the production. So, and why this works I can tell you right now. So, about the weight reduction. If you use a quadruple light glass with 2 millimeter glass, which you can use right now on the market, if you add the glass thickness, you get up to 10 millimeter of glass which is in use in the IG unit. The double glazing have about 8 millimeter glass which is in use, and the triple glass, standard glass, which is on the market, have 12 millimeter in use. So you get up to a weight from a quarter loop IG unit which is between double glazing and triple glazing. So it gets much lighter than a lot of people think about. The next step is, if you use a weight reduction with a 0.9 millimeter glass, you get a quarter loop IG unit which gets down to a double glazing. So you see there is as well future possibilities in there right now. The advantages of the weight reduction are you have lesser loads on fittings and frames, you have lower operation and installation costs for the whole window, you have better working conditions for the employees in the whole value chain of the production of the IG unit and the window, and at least, which is a very big impact factor in the carbon footprint of the whole window. If you use a 4 millimeter float instead of a 1.8 millimeter thermally toughened glass, you can save more than 16% of carbon footprint, which is really a huge impact. A big impact you can see as well. Oh, where is it? Do you see the graphic in there? And Claire?
Yes, Andreas, not yet. We don't see the graphic yet.
Mm-hmm. Is it possible to get them?
It was on your presentation?
Yes.
So we should see it. I don't understand why. Here?
No.
No.
It's a big graphic, which should be here. It's about the potential of carbon footprint.
Yes, I don't know why it doesn't appear. Let me check on the presentation. Slide number 11, right? I will try to show it from my screen. I don't know why it doesn't work from this. So just a moment, I'm doing the change. Share my screen. Yes.
Perfect. Thanks a lot, Inkler.
And then I will switch again to your presentation. It will be more convenient. Okay?
Okay. Yep. Perfect. So. Do you already see anything?
I mean, we see my screen here, so we see the graphic. No, no. The one don't see it. Okay.
Just let the window like before. It's okay.
Okay.
It's only a few words there.
So. Just remove the full screen mode. Okay.
Mm-hmm.
So now we are on your presentation again, but the graphic is still missing. So if you wish, Andreas, I can go back to my screen, but it seems it was not. Yes?
Yeah, it could be small, so it's no problem.
Okay. Okay, so. Now it's working.
Yes.
You see it? Yes. Okay.
Yes, we can see.
Okay.
So on the left side, you see a single glass with 1 millimeter float, uncoated, and on the center you see a double glazing with 1 Louis coating, which we used in there for the start point of view. And if you see there, a single glass uses 400 times more energy in the whole life cycle than this double glazing with 1 Louis coating. So it's really huge of energy you lost during the time. If you see on the right side, on the top, you have there a graphic which tell you, it's from Glass for Europe, how much of single glass is in use in Europe right now. And we have there 44% of single glass which is in use. So at least if you use standard technologies which are on the market right now, we have a big impact on the goals of carbon footprint for the European Union if you use there at least the double glazing. But if you use new technologies, at least you can save at least 35% to this standard double glazing right now on the market if you use a quarter loop IG and so on. At least the amortization of the energy use for the production of this IG unit, you have at least for the double glazing, you use only for months to get it in. If you use at least for a quarter loop IG unit, it takes 3.5 years to get in the energy you use for the production. But you see, it's very small time to get this done if you use the right materials. If you use like argon, if you use the krypton, you will have about 600 years and so on. Good. So, for me it's okay, you can change.
Okay. So I go back to presentation.
Mm-hmm.
Right, you have the floor.
Thanks a lot. So we have not only better performances when we use lesser material in form of weight and carbon footprint, we have as well better performances in the optical for the IG unit. At least on the left side, you see the graphic from the standard glass, triple glass with 4 mm float. We have on the outside a deformation when you use it in -20 degree and 20 degree of 5 mm on the outside and 4 mm on the inside. If you use an asymmetric design on the same conditions with a 4 and 2 mm glass, you have on the outside 1.7 mm deformation, on the inside the 8.6 mm. In real, it looks like you see this on the picture. On the left side is the symmetric design with the triple glass 4 mm float, and on the right side you have an asymmetric design with 4 and 2 mm glasses. So there's at least a big influence in the optical view of the glass when you use or reduce the glass to their requirements. The other opinion we can do is to use for the openable window, we don't need a frame. So we can use there a frameless openable window, which we have shown in our facade stand. There we used for the device an automatic system, which is standard on the market. We used in their profiles, which are standard on the market. So we used only their new technology for IG unit. But you see on the left side there is no you see no difference between openable and not openable window. On the outer side we have windows which are not openable, on the centered glass which is openable, which could be interesting for the design of a facade. A very important stuff the innovation on the quadruple IG unit was in there, that we were able to pass the climate change test. Normally some double glazing have problems to pass the limit of 1% a year of gas loss. And we had two tests there. One was 0.65% a year, and one was 0.56% a year, with the full package of 70 mm of IG unit in the test, the standard test from 1279.3. So we have a very long durability for our quadruple IG unit. The next thing I want to tell you, we use there to get tempered thin glass. The standard technology on the market is a roller furnace technology. We use in there an air cushion system where we have an symmetric energy input. So it's from top and for the bottom is the energy input. We are able to use the energy input on the maximum of convection, which is very energy safe and very fast. We have no touch to the glass, like here, and you can see this influence on the surface of the glass. If you have a look on the right side, on the bottom, you see there the air cushion system is on top and the roller system is on the bottom. You see there are a lot of roller waves, which we have not in the air cushion system. So at least there is really big difference as well in the near optical view of the glass. and at least we can save up to 40% of carbon footprint in the tempering production at least. The status quo of the use of thin glass for IG units is we have the thin glass regulation changing, which was changing on the September of last year. Therefore, we are able to use a 2 mm glass for the tempering in the air cushion process. We tested the quadruple IG unit and the 1279.3 on part 2 and 3 and passed all these tests. The next step to get, if you use this IG unit in a facade, you at least have to put in there some laminated glass, at least for safety regulations. We use as well this lamination process to get in there on the outside or on the inside the functional integration into the IG unit. We use a technology where we are able to do on the outside an edge sealing. This edge sealing have 700 times better water vapor diffusion than a standard lamination process where the foil goes on the outside. So, and the second option is that we are able to use their other foils because we don't have to take care about the water tightness of the foil because we have there another sealing method. We can take care about the lamination advantages of this material. So we are able to use their materials which are less than 100 degrees of lamination temperature, which are very important to get in there for sensitive electronic materials like OLED or OPV, which are very sensitive about lamination temperature. You can see here there is an OPV from our partner Electric on the left side. On the right side is there the OLED we used in the demonstrator from Philips. And we passed all the tests. At least OLEDs are very sensitive about oxygen diffusion and water vapor diffusion, and it's really a high quality encapsulation system because we're able to use these materials in it. Another function we used in MEM4MEM project was the micromirrors. The micromirrors are produced at the moment on the 10 by 10 centimeters in labor, and you see on the closed state is really dark. You have this is a material, also the mirror material is aluminium, so it's like you have a thick aluminium coating on the glass from the reflection, but on the opened window you have a really high transparency. Therefore you see these are very small micrometers. You have their distances about 60 micrometer, and the influence how to regulate it, you put in there 80 volt of supply voltage. You don't need any energy if you hold the status quo. It needs only the voltage. If you are changing the position of the mirror, you need there a low energy. So it's very harvesting of energy. And at least this makes it possible. Therefore you see a demonstrator of the micromirrors. On the left side it's opened, on the right side it's closed. And you see there it's not only for shading, you can as well control the light, how it gets into the room. If you use an angel like you have it right here, you can put on the light onto the ceiling of the room and get at least the light in. Another demonstrator we used, these are at least shown 3 demonstrators of the 32 demonstrators we made in the project, where we want to show sellable products. We decided to put there in 2 decades, one which are sellable, one which are technically possible solutions. Therefore we see the sellable products in there. The solar thermal collector they are sellable at least. They have at least a high TRL. We have the optical efficiency of more than 80%. In vertical implementation, we have in there in this demonstrator a functional piping system. We have in there the OPV and the quadruple IG unit with the 2mm glass. And at least you can see, if you use their smarter design, you can integrate functional stuff with a low-cost solution. You have a U value of 0.3 watt per square meter Kelvin. We have a very high transmission. At least if you use antiferritic coatings in the glass, you can get to a higher transmission than to a triple glass. We have a very high durability. We have a very low weight, a very low carbon footprint, and at least if you use a smart design, you have as well a very high optical quality of the facade. So, thanks a lot for your attention. If you have any questions, at least you can ask. These are the contacts of all our partners and their results, and you can as well contact me if you have any questions. You can ask at least right now.
Okay. Well, thanks a lot, Andreas, for this very interesting and comprehensive presentation. So we will now enter the Q&A session. So if you have any question or comments or exchange of best practices, just raise your hand with the appropriate button and I will give you the floor. We have the first question by Regis. I will give you the floor, Regis. Regis, you can raise your question loudly if you wish. No? Yes, he's coming. Also, Andreas, you see Regis' question in the chat.
Yes.
Do you see it? How do you control shading levels? Is there some IT components embedded within the smart window?
Okay.
Okay.
You can control the shading systems. There's a lot of millions of micromirrors in there. How you are connecting them together. So you have to know before you design it which segments you want to switch together and which you want to switch extra. Then you have the possibilities about the sections which wire you use to switch on. So you have to do it more first mechanically, at least. It's not there any LAN connection or any other networking which you can pin each pin. So it's how you connect them in your product itself. Is that question, was it right for you? Was it okay for you?
Hello, Regis?
Hello?
Hello, yes, we hear you, Regis.
Okay, sorry. Okay, so I got the answer. Thanks very much, Andrea.
Thanks a lot.
So a new question. from Sandrine and Francisca. So I will give you the floor.
Yeah, hello.
Hello.
Good afternoon, everyone. I have just one question, which is regarding the price of this quadruple IG unit in comparison to a classical window. I'm just really wondering how much this would cost.
At the price, I can give you only a small direction because we are there on what's it called? We have the contracts that we are not able to say. It's a how's it called? Confirmation. But you have at least, if you compare an IG unit to a triple glass to a quadruple glass, you have there the extra costs of the extra sheet. You have there the extra costs of the tempering. But at least if you use there a frameless design, you don't have the cost of a frame. If you compare a standard window, the cost intensive part in the window is that the IG only costs 1/10 of the whole window. 9/10 of the window costs the frame. So we can, if you use their frameless window where we have at least an inner frame, it's only the frame from the window which is openable, which we don't need. We have there in cost saving about 20% at the moment.
Okay. And you can use this kind of window in renovation?
Yes, you can use this as well in renovation. What you cannot do right now is where we have problems if you use the same frames which you have right now in your building, because these frames are mostly regulated that it have to be a size lesser than 60 millimeter right now. So they are not wider than 60 millimeter.
Okay.
And therefore you can get to troubles if you use at least the same frames like that. But it depends on your supplier. Some suppliers are able to get this volume in. Otherwise you have to use, at least if you want, krypton for the glass, then you get to this U value. But you have to know that at least if you use krypton, you need more energy during the production than you ever get in with the glass. So on your decision then.
So actually it's mainly for new construction.
Yeah.
Okay. Thank you.
Yes, Francisca, I have a question as well. I would like to know, when do you think that the quadruple light windows would be available on the market?
It depends to our customers. We are machine suppliers, and we have there the point of view that we want to give everybody the information about the product. Everybody will get each supplier from us. But it depends on their speed. At least I was in August at Scala, which is a Finnish customer of us, and he wants to get the quadruple IG unit very fast on the market. So probably could be done next year, at least.
Okay.
But I don't know right now his status quo.
Oh, okay.
At least I know Energy Glass is very interested, which is a partner of us. But depends on their timetables to get it done.
All right. Thank you.
Thank you.
Is there any other question or comment from the floor? Julia, I unmute you. Julia, you are free to raise your question.
Yes, hello. Can you hear me?
Hello?
Hello?
Hello, this is Julia. Can you hear me?
Yes?
Oh, hello. Hi, thank you. I have just a very quick question, which is really interesting. Do you also have an estimation of the production of energy from the solar component. So what is the, let's say, per square meter of window, how much is the energy collected, both the thermal and the electrical energy from the solar component?
I didn't clearly understand your question. Do you mean about the glass itself? Where does it get produced, or what do you mean the functionality in the glass where it's produced? Hello?
I was wondering about the components, the PV cell, the solar thermal collector in the IG unit, if it's something you can comment on.
The solar cell depends. We are open, at least in our encapsulating chase system, for each system of PV material. The demonstrator we did with Electric, so they sent us the OPVs and we laminated them in our company in Austria. So a future solution could be that customers of us will get the materials to their companies and do the lamination process in their companies, and then use this PV module, at least what it is, into an integration in the IG unit.
Okay, so the conclusion is that it depends on the kind of application, but in principle it can be done technically.
Yes, at least.
Okay, okay.
For the OLED, at least, it's a little bit more difficult because they are very sensitive about oxygen and the water vapor. OPV is not as sensitive. Therefore, we have no solution right now at the moment. So
that is very interesting.
at least they can send it in small glass samples, which you integrate in a PV module. This is a solution you can do right now, but therefore there will be future solutions which are much easier to integrate, because we want to print directly on glass and so on.
Okay, thanks.
Okay, thank you.
Any comments or no? So, if there is no any further question, I will give the floor to Sandrine and Franziska. So I will stop sharing this presentation.
Thank you.
Thank you.
All right. Sorry, which slide is this?
Yeah, actually it's a slide I can present it. I added it a few days ago. Yeah, so I just wanted to stress the opportunity we give to EeB PPP projects regarding the ECTP conference. I guess you all know the ECTP conference is taking place next month in Brussels on the 17th and 18th November. So we thought it would be a good idea to exhibit some innovation cases on booth during these 2 days. So innovative proposals from the EeB PPP projects are of course very most welcome and will be given priority. So Julia, Michaelis, I think Michaelis left, but if you have any proposal, just drop me an email and we can propose you to present your innovation among the EC representatives. So actually the EC representatives are very keen on seeing such innovations being presented and communicated. So yeah, I just wanted to highlight this opportunity for you. And Sandrine and Franziska, you can now switch to the next slide. Yeah.
Okay, all right. I would also like, just as a conclusion of this webinar, present some more activities of the EeB CA2 CSA, where all projects can get involved in. Just as Anne-Claire just mentioned, next to the ECTP conference, you can on the one hand have the booth, but you can also participate in our EeB matchmaking event. To participate in this one, you don't need to register for the ECTP conference, so it's free of charge. You can just come here in the afternoon of November 18th. It will take place from 1:30 to 4 p.m. And it allows you to meet stakeholders along the whole energy efficient buildings value chain to negotiate about new proposals, new research projects, but also businesses just besides Horizon 2020 projects. We also have this opened to participants that are not project partners in any EeB projects, so that we really get a wide variety and range of stakeholders. So if you're a planner for like an architecture or a city planner, building planner, construction company, or even a municipality, or even investors can join this event and meet each other and exchange on new collaboration opportunities or financing opportunities. The meetings can be booked ahead on the website of the matchmaking event. So once you click on the link, you can see the already registered participants. You can register yourself, upload a profile, and also a cooperation offer or request. And this is possible to do until the November 14th. Other than that, what you can also do in EeB CA2 or together with us is participate in the coaching service, the so-called innovation assessment. It's an assessment that we offer to all project partners of EeB projects. So coordinators of project can forward this information to their project partners. It's especially interesting for SMEs and applied research partners that are interested to commercialize their innovations and technologies they have developed in EeB projects. The first step would be a self-assessment where you can just get some clarifications on your innovation potential and competitive potential towards a certain technology or innovation, and we will do the analysis for you, and then in a third step discuss this together. It's also free of charge service, so we still offer it until the end of January, so if that's interesting for you or for your project partners, you can contact us on that. Last but not least, we would also highlight that you can still join our LinkedIn group of the ECTP community. So this LinkedIn group is already filled with more than 700 members. It helps you to find out more what's going on in the other projects, but it also allows you to share any information you have on your own project. So if you have any new deliverables that you would like to be published, any events or newsletters, you can always go and join the group and publish them there. So that's from my side. I give the floor back to Anne-Claire.
Yes, okay. Thank you, Franziska. Well, from this is it from the EeB CA2 CSA. So if no one has any other question or comment, we can close the webinar. Thank you very much, Andreas, and thank you very much to all the participants for being with us. And so as you know, we organized, this was the first webinar, and we still organize 6 other webinars between end of October and early November. So if you wish further information on the webinar we organized, just send me an email if you did not receive the invitation, as you are not a member of the specific working groups. Yeah, so thank you very much to everyone.
Thanks a lot to everybody.
Thank you.